Okay, today let's go with an important logic, that is prime number related. So, what is prime number? So, we knows about a prime number. If a number has one and itself is the factor, so then it is called a prime number. If it is divisible by one and that number itself is called prime number. We knows. Uh, for example, if I take a particular number, some x is equal to 5, just I have to check whether this number is prime number or not. So I need to check whether it is divisible by 1, 2, 3, 4 up to that n minus 1. So if we are not considering 1, so that time simply we will consider 1, 2, 3 up to here we'll consider. Yeah. So we can write the formula 2 to that x minus 1. Till there, we have to check the factors, whether there are any factors from 2 to that number minus 1. Till there, we have to check every time whether it is divisible by other numbers or not. Means we have to find out the remainder value. If there are any factors except 1 and that number itself, then that is not a prime number. If there are no factors except those two, 1 and that number itself, that is called prime number. So shall we write a small logic for this? We can call it as an algorithm. So for example, here I am taking some x value. Whether x is prime number or not, I have to check. How can I check? X is equal to, for example, some number I am taking. So let it be. I don't know which number it is. For any number, it has to check. For any number, it has to check whether it is prime or not. So this time, so we will generate a logic. So we will divide here. We'll divide whether that we have to take that 2 initial value is 2. So the we have to start from 2, 3, 4, 5 up to that particular number, whatever number we have given. So initially we'll start with 2. For example, here I'm taking some I value is equal to initially 2 I'm taking. Here afterwards I'm checking I modulus that particular number x, whatever the number we are taking in x is equal to 0, then it is called a prime number. Sorry, yeah, it then 2 will become a factor for that. Then again we'll check with another next number, then I plus plus. So we'll repeat it up to I lesser than that particular number, whatever we are taking x. So it must be lesser than x value, even not equal to that x, because we are taking n minus 1, So up to there we are taking. Observe here, while this x value is repeating, sorry, I value is repeating. Initially, for example, I'm taking a loop that is called a for loop. Here, I value is initially 2. I'm starting with 2. So x value we don't know for which number means it is prime or not. For which number we are finding the factors. So that we are keeping in x. So here what I'm telling, till x minus 1 we have to find whether there are any factors or not. That's why here I'm taking lesser than x means all will be lesser than x, not equal to x. Till there I am checking the factors. I'm starting with 2, whether this x is here in reverse I have written whether x is divisible by that 2 or not. Whether x is divisible by 2. 2 means here I am taking in the iteration value I. So x value, is it divisible by that 2 or not? If it is divisible by 2, simply we'll take a flag, some flag or some flag value is equal to some 1. So if the flag value is 1, surely that is having another third factor. So that's why if it is having a third factor, surely it will not be a prime number. Likewise, I can consider here. So again, x value will become 3. X modulus 3. If it is not equals to 0, will not come inside. The flag value will be initially, here flag value will be initially, I'm taking flag is equal to some 0. I'm taking initially 0. So it will keep on check till that x minus 1 value. If there are no factors, will not come inside. Flag value will always be 0. Whenever it is equals to 0, then flag value I'm keeping it as 1. So finally I'll come out and whether if I'll come out from this block, if that flag value is equal to 0, then only it is called prime number. Prime number. If it is not equals to 0, else sorry, if it is not equal to 0 means some factor will be there, not prime. So like this, I can draw a small logic, small algorithm. So I'll keep on increment the factors, checking factors. These for this purpose, iteration purpose, I am taking some I is variable. So here x value means initial to which number we are checking the factors, that I am keeping in x. So always x modulus 2, x modulus 3, x modulus 4, likewise I'm checking. If x value is 5, so this will be repeated for uh, 2, 3, 4, means this will be repeated for 3 times. So here 5 modulus 3, 5 modulus 2, surely it is equal to 1, means the condition is failed. Next 5 modulus 3, again it will not be 0. Next 5 modulus 4, again it is not equals to 0, means we will not get the flag value as 1. So by default flag value we kept 0. So we will come out and we'll check whether if the flag value is equal to 0, then it is called a prime number. Otherwise, not a prime number. So this is a simple logic to check whether the given number is prime or not. So let us do the program now. Small program. Hash include stdio.h int main. Here, let us take the value dynamically. So here I'm taking some integer value x to hold the input, and flag value is equal to 0. I'm keeping let it be. So now I'm for iteration purpose we need one variable for iteration purpose. Here I'm taking some I. So here I'm prompting printf enter an integer. Enter an integer. I'm taking it into x percentile d. That is an integer number. That's why the format specifier I'm taking ampersand x. I'm holding it in x. Then now our logic will start. Here I'm taking a loop. Initial I value is equal to 2 I'm taking. Next, I is lesser than that X value, then I plus plus. So this loop will be repeated. So here I am taking, if that X, the initial value which we have taken, I am dividing with the iteration, that is iterative value 2, 3, 4, like that, till that X minus 1 value. I am going to check the factors. If it is equal to 0, that will be a factor. So I am taking flag is equal to 1. I am checking. If it is not equals to 0, here it won't be equals to flag equal to 1. By default, that is 0, which I have kept. If any single factor I get here, then flag value will become 1. Whenever it becomes 1, I need not to be here. Means whenever it becomes 1, I will come out and I'll declare. If any third factor I got, here I'm taking break statement. If any third factor I got except 1 and that number itself, single factor, then it will become means not a prime number. Third factor it is getting, that's why. So afterwards I will come out even from the for loop. I am checking flag equals to if flag equals to 0, printf backslash n percentile d is a prime number. Comma x, else printf backslash n. Sorry, we have to write percentile d. Here percentile d is not a prime number. Not a prime number. Backslash n. Comma x is a variable for that reference. Then return 0. Okay. So it is the logic for prime number. Simple logic to check whether a given number is prime or not. So let us check GCC space prime.c. Let us check is there any errors, no errors, dot slash a dot, enter any integer. I am taking 5. 5 is a prime number. There are no factors. Yeah. Next, give another number. For example, 10. 10 is not a prime number. Not a prime number. You can check some 57. I am checking. 57 is not a prime number. We have now 13. 13 is a prime number. Yeah. Some 97 I'm taking is a prime number. So whatever the value we give, so that will check. This is one concept. Now, by using this, let us do one more concept, that is print the prime numbers from 1 to 100. Print the prime numbers from 1 to 100. So, or from 2 to 100. Whatever the prime numbers we have from 1 to 100, print all the prime numbers. Print all the prime numbers. How can I print those all the prime numbers? So now the logic somewhat means different, means it will be changed somewhat. Here instead of x, here we were started from x. Okay, we were started from x. So instead of x, we have to check for each and every number. That's why here I am going to take another variable. For example, j I am taking, means Instead of X, here I am taking J. Here J value, I will change each and every time. For 5, we have checked whether it is prime or not. Here, instead of 5, I am taking some variable J. So the J will be every time repeated. I am starting with 2. For 2, 2 is a prime number or not. For 3 is a prime number or not. 4 is a prime number or not. Likewise, I am going to check. So this time I use another loop. For here J I am starting with 2 and